Okay, so same thing. Alright, we have a low pass filter A over S plus A. Okay, and however the question asks you that what if you have a 1 delay. Okay, find the equivalent transfer function in the z domain. Alright, if you still remember in the l9v2 video, alright, just take a look. The conditions are all there. I'll not go through that. This is only purely on practices. So if you don't know anything, you'll just watch the video and then bam. So if you have this type of thing going on, the order of your the order of pole minus order of 0 minus number of delay is equals to number of 0 required. Okay, I think this is something that you will need to straight away memorize lah. It's more easier than the conditions in the l9v2 video, because after now I do this, I think this definition is more stronger. Alright, it's easier to memorize also. So the order of pole is now what? 1 minus order of 0, there is no order of 0, it's just some constant, so therefore it's just 0, minus number of delay, there is 1 delay, so it's 1. So in the end, 1 minus 1 is equals to 0. Alright, 1 minus 1. Alright, 1 minus 0 is 1, and then 1 minus 1 is 0 lah. Alright, so the number of 0 required in your transfer function is 0, or the number of hidden of number of 0 is 0. Okay, so therefore for this case we can straight away evaluate this transfer function. Okay, so therefore how can we evaluate? I'll just straight away evaluate the poles, because there is no zeros at all. This is just constant. So if I were to evaluate the poles, the S, I should just step by step lah. Okay, so A over S plus A is equals to A over, alright, Z. So I'll just sub in S is as equals to Z lah. Okay, and then S minus A. Damn, I should have write as S minus A first. Okay, so M minus A is equals to plus A, and then is equals to A over now I can sub in S is equals to Z, right? Because it's just the definitions. The definitions comes from l9v3, I think. So if you don't understand, you just watch l9v3, or I just suggest you watch all this video first, and then after that you can go on to what we're going to do now. Alright, next, minus A, sorry, now this particular step is that I officially transform from the S domain to the Z domain. So S straight away equals to Z, while the minus A over here I'll just write as E minus AT. If it's minus B, I'll just write as E minus BT. If it's minus C, I'll just write as E minus CT. If it's C, then I'll just write as E to the power CT. I think you get what I mean already lah, okay? So therefore this form is your sorry, and I should also ignore the A. I'll just write it as 1 will do. Because if you were to transform in the S domain into the Z domain, you're only looking forward for the poles, and if you have a zeros, you transform the zeros. The constant, A is a constant only, there's no zeros and poles. Okay? So therefore the constants will evaluate in terms of K. Okay, so over here I'll have a K. Okay, so this K is a representative of your A over here, some constants value. Okay, but it's not directly there, but at least this is what you need to do. Alright, so normally the first step first, write in terms of this form. Alright, and then after that you evaluate the poles, because you evaluate the zeros if you have zeros, and then together with the poles. So if you want to transfer from S to Z, alright, please take note that only look at the poles and the zeros only when you go into the Z domain. And then at the end of the day, when you evaluate everything, sub in the K, and then after that, now you find the K. Now this is the purpose of what's doing now, is that having this thing, which is equals to your transfer function HZ, alright, we're going to take these definitions, and we're going to write it in terms of, I'm going to put it over here. Now, I need to find the magnitude of our transfer function, alright. So I'll just simply sub in as S is equals to 0. Alright, because I want to find my K. In order to find my K, I need to know initially what is my system. So in order to find initially what is my system, I don't put in any frequency to run the system. I just don't put anything into the system and see what is the k itself. So when s is equals to 0, alright, s is 0, so a over a is equals to 1. Alright, so I have this 1 over here. Right? So when s is equals to 0, z is equals to 1. Because in the s domain, bam, again, this is in the s domain. In the z domain, you can just straight away put it over here at this side. Alright, in the z domain, if your transfer is there. If you don't know anything about the mapping, then you just watch L3, V7, V8, V9, 9.1. Watch these 3 videos, okay, in the playlist. Alright, so over here, at this particular step, what I'm doing is actually to sub in when s is equals to 0, z is equals to 1. Okay, my purpose over here is to find k already, in case you don't know. Alright, at first what we do is that we're trying to find the transfer function first for the z domain. So first step, you find your transfer function of the z domain, and then including your k is some constant that we need to find. So the second step is that when you sub in s is equals to 0, z equals to 1 into your transfer function, then you can find your k already. Alright, now we are one step towards finding k. Alright, but just to take note that if you were to evaluate the hz when s is equals to 0, just take in the true a over s plus a. Alright, this is discussed in the previous video. So if happen that you didn't watch that, I just suggest you watch the previous video. This is l9v what now it's l9v6. You just watch l9v5. Okay, so previous video we have a zeros over here, for example s minus s plus infinity. So if you were to find the k, when you ask to find the k, okay, exclude the additional 0, the hidden 0, just only take the pure this thing will do. Alright, so I hope that this is pretty clear. And then you take this thing, you sub in s is equals to 0. Alright, then you have a over a is equals to 1. So this thing will be over here. Okay, so I hope that this is pretty clear. Although I think a bit unclear over there because I'm rushing my time. But anyway, so now we just simply rearrange stuff because this is at the denominator. I can just bring it up. Alright, and then this is the numerator. If you bring it down, it's just simply divided by 1. So therefore my k is equals to 1 minus EAT. Okay, over here. Alright, so if I were to sub in my k as equals to, so this is my transfer function, right, which is over here, then I can just simply sub in my k as this one, right? Ta-da! So over here, this is my k. Alright, and that's it. This whole thing is your transfer function for your z domain with, alright, a over s plus a with a delay, with a 1 delay. Okay, and you may wonder what is the 1 delay. Is that the delay itself normally is to allow computational time in the computers or whatever to calculate stuff. Alright, so therefore normally we want a 1 delay to allow the computer to calculate. But in a more detailed way, leave it to your future. See you there soon.